I know there's some people out there. Okay. Not quite 140, or at least. Five. Okay. Okay, let's get started. Welcome, everybody. This is, I guess, the first ITS seminar presentation of the spring quarter. My name is Deborah Salon. For those of you who don't know me, I'm a research faculty member here at ITS, and I'm very happy to be introducing our seminar speaker for today. This is Tom O'Brien. He is a planner. He has a PhD in planning from the University of Southern California. He is the executive director currently of the Center for International Trade and Transportation, as it says up here, at CSU Long Beach, Southern California. He's also works a lot with folks at USC, and he's the associate director for their METRANS Institute. What does that stand for? Metropolitan Transportation. So today, his work focuses on institutional and policy aspects of freight movement. And today, he's going to talk about the relationship between equipment management and terminal productivity. I think with that, I'll hand over the mic and let him start. Let's give him a welcome. Thanks.
Attach this. Oh, it's working. Attach this so I don't
have to hold it. Well, thank you for having me, everyone. It's really good to be here. And one other thing we should add to the bio is that we are now part of the National Center for Sustainable Transport, housed here at UC Davis. So we'll be doing some of the freight-related work, some of the training work in partnership with UC Davis. So particularly happy to be here to be talking about a lot of what we do in Southern California. Usually when I do a presentation on chassis, there's sort of two groups of people in the room. It's the people who are like, hey, finally a presentation about chassis. And the other people who sort of have this odd interest in, what is a chassis and why would anybody want to talk about it? So I imagine I've got the full spectrum here in this room and some in between. This is research that we've done funded by Metrans. And I've done it with a partner, Handam Lake Griffin, who is attached to the Viterbi School of Engineering at USC, and who's also a port engineer. So my perspective is policy, institutional analysis, and logistics. But I think the presentation should have a little bit of something for those of you who want the optimization, scenario development, modeling side, some of the people who are interested in the policy, and then the economics of goods movement. And that's what we'll talk about today. The focus is on how equipment management impacts the productivity of marine terminals, which in turn impacts the productivity of the supply chain as a whole, because the ports are part of a system of actors that move goods from wherever they origin, wherever they're manufactured or sourced, to where they're ultimately sold. Oops, that was not... There we go. Because I don't want to assume a lot of knowledge about chassis management in this country, I'm going to start with a little bit of context, historical context and the background on the changes in equipment management for freight and why it's the motivation for this particular research project. I'm going to talk a little bit about traditional chassis management practices in intermodal transport and the catalyst for change and new models for equipment management with a focus on chassis. The potential benefits of stakeholders pooling their equipment, the chassis pools. I'll talk a little bit about what's happening in Southern California and then talk about this particular research project that's looking at tying changes in the way chassis and equipment are managed and their potential benefits from an efficiency perspective, and we'll also talk a little bit about from an air quality perspective. My sense is we'll take this up till just before 2:30, and then we'll have time for questions, if that works. All right. So to start us off, I think we might as well begin at the beginning when we're talking about discussion on chassis. And what is it exactly that we're talking about? The focus is going to be on the intermodal chassis. So this piece of equipment that makes global trade in many ways possible. Right? The container, the ocean container that comes off of a seagoing vessel can be put on for the most part, any chassis. They're interchangeable. That's the benefit of an intermodal system, right? It gives you efficiency, flexibility in the system. And we'll talk a little bit about why intermodal equipment management is different in this country. Now, the chassis are flexible enough, right, so they can be detached from the cab, the bobtail, right, and can be stored on a marine terminal so that a container can be placed on it. They can carry different size containers, right? Is anyone familiar with the term TEU? Right? TEU is the standard measurement of an ocean container. It stands for 20-foot equivalent unit. The majority of containers these days internationally are 40-foot. But an intermodal chassis can handle both of those. Right? You've got triaxial chassis, which handle oversized containers. You've got chassis that handle refrigerated containers. The point being is that the ability to move and detach equipment allows for a more fluid system. Okay? When we talk a little bit about why this is an important topic, a couple of points come to mind. The first is that we handle our equipment different than every other place in the world. And it's worth knowing why that's the case. Right? And as I'll move down, we'll talk a little bit about how we got to the point we are in the U.S. It's also an important topic, broadly defined, because there's a lot of equipment in service in the U.S. That needs places to be stored, that needs repair and maintenance, and that needs to be fueled, right? There are about, as of now, somewhere in the range of 640,000 registered pieces of equipment in North America. And that's by a group called the Intermodal Association of North America has something called a Global Intermodal Equipment Registry. Right? And it's a registry, it's a voluntary registry that helps track the movement, ownership, and interchangeability of these pieces of equipment. So 640,000 is a lower number because there's going to be unregistered equipment out there. It's an important topic for us in Southern California because a fifth of that equipment is in operation in and around the ports of LA and Long Beach. So a significant number of pieces of equipment. It's an important question because 32% of those chassis are owned by ocean carriers, and that's the piece that I want to talk about a little bit further. They're owned by ocean carriers, right, which is different than the way the rest of the world operates, which makes for some interesting, complex equipment handling questions. 30% of all container terminal transactions are associated with a foreign chassis, which means that 30% of the time when a truck, a cab, chassis pulls into a marine terminal with a container on it, that chassis doesn't belong there. Right? And it has to be repositioned back to where it belongs. That's what we're going to talk about because that puts into the supply chain a lot of inefficient movements back and forth with economic and air quality impacts as well. And it's a land use issue as well. But because we have so many pieces of equipment, about 10% of all terminal acreage in Southern California is devoted to chassis storage and not being used for the movement of goods, right? And the question is that the highest and best use for marine terminal to be storing equipment, right? It's an important economic question because it costs the intermodal equipment management, chassis specifically, cost the industry about $2 billion a year. It's $8,000 for each of these new chassis. Right? So you want to make sure that they're being used correctly, effectively, repaired and maintained appropriately. And it's a good time to be asking about how terminal equipment is used because we're seeing some new incentives for change on the part of ocean carriers and terminal operators who really can dictate the way the industry behaves. And some of these drivers are economic, right? Some of these drivers are regulatory, and we're going to talk about that. And it builds nicely upon some of the work that's been done previously about the way terminal operations can be modified to make for a more fluid supply chain. But most of the research has focused on delays outside the gate, so truck queuing. And we're interested in how what happens on the marine terminal influences what happens outside of the gate. So for us, that was a useful question to ask. And needing to understand how congestion inside the gate influences congestion outside the gate. All right. So that's sort of the framework. Any questions about that? And please feel free to interrupt me if things are not clear or if the vocabulary doesn't make sense. Okay. In the U.S., historically, ocean carriers have provided the intermodal equipment, the chassis and the container, to the trucking community to use to deliver the goods. Everywhere else in the world, including in Canada, the equipment, the chassis, is brought to the table by the truck driver or the shipper, the person who receives the goods, who owns the cargo that's being shipped. Right? We do it entirely differently in this country, and that's for a couple of reasons. One is that containerization, the use of the ocean container to transport goods, began in this country. And ocean carriers saw the potential to reach markets that were distant from the port for major clients and customers if they had the equipment to provide what we would call store door service. That means that you could contract with the ocean carrier, and the ocean carrier would make sure you got your goods from where they were being manufactured to their store, right? And so there were benefits in terms of volume in investing in equipment because there was a payoff in the end on guaranteed deliveries, right? This was not the case in Europe, where you had many different regulatory issues. This was before the EU, right? Anyone know when containerization started? Relatively new phenomenon. 1956 was when Malcolm McLean, who was a U.S. trucker, sort of retrofitted an oil tanker and moved goods between Houston and New York, right? And we didn't get to see the development of major intermodal container infrastructure until the 1960s. So it's a relatively recent phenomenon. And one of the tools that was developed to reach those interior U.S. markets was also to create an intermodal rail system where you actually put what we would call COFC, containers on flat cars, and TOFC, trailers on flat cars, where you could actually put the chassis and the container on a rail car and ship it. Again, a different situation in Europe where you had different rail gauges, you had different countries, different regulatory issues. So things took off differently in the U.S. And so the ocean carrier said it's in our best interest economically to invest in equipment to service the markets that we think we have across the country. And now we're dealing with that legacy, right? But what it means is that you have a lot of different people touching the equipment, some of whom have control over it and others who don't, right? So you've got the terminal, which has a contract with the ocean carrier, but they don't really own the equipment either. They have to be a place for it to be stored, right? You've got the trucker or the drayman, right? Is everyone familiar with the term drayman here? Dray? What the origin is? No? So here's a useful fact to entertain your friends with. The term dray actually refers to an old three-sided cart. And in the days before containerization, you would have people who were in the cart business go down and unload palletized goods and bring it to the area adjacent to the port. And very often those cart companies became the first of the port trucking community. And so we still refer to the term dray or drayman as short-haul trucking. And it's very often used in the context of movement between ports and distribution centers and warehouses, right? So they're the ones that are dispatched to pick up a container on a chassis that they don't own. You've got the yard equipment operators. So these are the longshoremen, the ILWU on the West Coast, the ILA, International Longshoremen Association on the East Coast, who have the authority to move the equipment while it's on the terminal. They have a stake in this. You've got truckers who are bringing in exports as well. And then, of course, we have the ocean carriers. Now, at this point in time, though, the business model as it currently exists may not be the best. And part of it is driven by the impact of the recession and current economic conditions on terminal operations, right? So just to give you a sense of the sort of the relative level of activity at two major world ports and the density of operations, take a look at the Port of Singapore and the ports of LA and Long Beach. The Port of Singapore is about 1,050 acres, and over the last couple of years has averaged about 27, almost 28 million TEUs, 20-foot equivalent units, those containers. LA Long Beach has 7,300 acres, and we move about half of the amount that Singapore does. As a result, there hasn't been an incentive to use the land as wisely because we've had available land to store chassis. Okay? Well, it's a good point. I think you're right. But you get, as a result, this is from one of the Long Beach terminals, you get a lot of stacked chassis. And you can imagine stacking them this way requires a fair amount of time, labor, which is cost, and takes up valuable real estate. That means you can't be flexible with your land use on the terminals when conditions dictate. Right? You want to be able to have storage available for exports or increased imports when they're available. And the downturn in the economy has created an environment in which terminal operators are saying, can we do this a little bit better? We don't want to be in the business of storing idle capital, right? And that's essentially what they're doing. In addition, the two ports have estimated that to be able to accommodate increased volume in containerized trade, they're going to need to make available 35% more land for container storage and processing. That right now, some of which is devoted to chassis, right? And so you've got hundreds of thousands of dollars spent on locating and consolidating and storing chassis that might otherwise be spent more effectively. And just to sort of drive home the point, we are talking about intermodal operations in different industries. The chassis is fully attached to the cab, and it's the truck driver who provides the equipment. So here's where we get into why this, in particular, doesn't make sense on a terminal. Now, if you remember, I said 30% of all transactions at a marine terminal, at least in the Southern California context that I'm familiar with from my research perspective, involves a foreign chassis, right? And a foreign chassis, now having had these few minutes of discussion, you know means that it's a chassis that is being brought into a container terminal to an ocean carrier that uses that container terminal when that piece of equipment doesn't belong to the container terminal, right? So somewhere you've got a truck that was dispatched to pick up maybe a container for export, right? So LA County is the largest manufacturing county in the country. You don't think about it that much, but so we do export a large amount of goods. So a truck driver is dispatched to pick up a container in Riverside or San Bernardino County and to bring it to the port to be loaded on a ship, right? Now the truck driver wants to make a revenue trip, right? So the available chassis is what he or she is going to put it on and bring it to the terminal. When the driver gets to the terminal gate, it's going to go through a scanner, and the clerk in a tower on the terminal is going to be able to determine whether the container belongs at this particular terminal and whether the chassis belongs at this particular terminal. If everything is great, right? If it's a chassis that belongs to the ocean carrier that the export container is going to go on and it's being driven on a chassis that belongs to the ocean carrier, the truck driver is going to be dispatched to that portion of the yard, right, where exports are stored directly. However, if the container terminal sees that the chassis belongs to another ocean carrier, they're going to require it to go to what we call a flip line. I'll just show you what a flip line looks like, and I'll explain what happens, right? A flip line exists because a marine terminal doesn't want to be responsible for finding on its many acres a chassis that belongs to another marine terminal. So to make sure that that doesn't happen, they require the truck driver to unload the container, and they move another chassis that does belong to the terminal from somewhere else on the grounds, right? There's a chassis UTR's utility truck, so it's yard equipment. So this is an area of chassis that belong to the marine terminal. Truck driver will come in. He or she will be told, you have a chassis that doesn't belong to us. At the flip line, they will unload the container. They will move in a chassis that belongs to the terminal. They will put the container on that chassis, and then they will take the chassis, and it will be placed in an export staging area with the chassis for it to be ultimately loaded onto the ship. The truck driver will then have to go to the outgate and take the chassis back to the other terminal. In LA Long Beach, there are 14 different container terminals. So it could be somewhere in a 10,000 acre area, right? Is that clear? It's a little confusing, but it's supposed to be because it doesn't make a lot of sense. But what this means is that not only do you have to have an area stored for the flip line, you also need to have an area for your own chassis, right? In addition to the area where imports and exports are staged. And to give you a sense, when we do terminal observations, this distance for each of the transactions back and forth could be anywhere from 1.5 to 3 miles. So it's not an insignificant trip that a piece of yard equipment is making. Right? And while the flip takes 1 to 2 minutes, it's fairly efficient. If there's a queue at the flip line, you could be adding 20 minutes to that transaction unnecessarily, which has implications for how quickly the goods get down to through the supply chain in a just-in-time operation. So, I mentioned the fact that the terminals might be ready for a change simply because with the recession, there was a lot of idle capital that they weren't using. They wanted to get out of the business. A couple of other things changed from the regulatory and policy side. In 2010, the Federal Motor Carrier Safety Administration adopted new roadability legislation, roadability standards, regarding chassis fitness. And up to this point, right, the practice was the ocean carrier was responsible for the chassis before it left the terminal gate. So they were responsible for doing inspections, maintenance, and repairs so that when a truck driver picked it up, it would be roadworthy. Now, on the road, though, if the California Highway Patrol stops a chassis and determines that it's not roadworthy, it's on the trucker. On the trucker. Because it's the trucker's responsibility to make sure that he or she is leaving the terminal with a roadable piece of equipment. The terminal operator has to do the inspection and pays for the maintenance and repair, but the truck driver's got to do the inspection before he or she leaves the site. As you can imagine, though, in an industry where time is money, and if you're a truck driver, you're not paid by the mile, you're paid by the trip. Your incentive is to get out of the gate as quickly as possible. So, for decades, there were a lot of inspections that were happening on roads where the truck driver would be paying for any fines or code violations that were discovered outside of the gates. This piece of legislation was designed to correct some of that by shifting the balance back to the terminal operator and the owner and the ocean carrier, the owner of the equipment. And one of the byproducts was that it created an environment in which you had more standard equipment because there was an incentive for all parties to make sure that the equipment was roadable. And this changed a little bit a situation in which ocean carriers use the quality of their equipment to brand it, right? So one of the things that Maersk, which is the world's largest ocean carrier, would say to its customers is like, we have our failure rate for inspections for our chassis is 1%. Right? That would be a way that they branded their equipment. The new roadability legislation created new standards that made it less likely that an individual company would need to brand its equipment on roadability because everybody should be meeting the same standards. Right? And so there would be less finger pointing over damage because all parties had equal responsibility. I mentioned the fact that we had the recession, which was an economic incentive for terminal operators to change the way they did business. But then that was followed by significant congestion. And ocean carriers were looking for new ways to handle increased volumes, particularly with peak surges. Let me explain that for a minute. The size of ocean vessels is increasing rapidly. So ocean vessels that were carrying 5 to 10 years ago, 6,000 or 8,000 20-foot equivalent units, TEUs. The biggest vessels are now carrying 10,000, 12,000, and this coming year, 18,000 TEU vessels are coming offline. What does that mean? For one thing, not every port has water, has infrastructure deep enough, or landside infrastructure to handle the largest vessels. So that means you've got more cargo going through fewer trade gateways at peak times, which creates a demand for equipment at peak times. And if we already have a problem with inefficient use of equipment, and some of it's not at the terminals, or too much of it is at the terminals, that's compounded by the fact that you now have peak demand that wants the equipment there to handle large vessels being discharged in a 24 to 48 hour period. So ocean carriers are looking for new business models to get out of the chassis business or change the way they handle business. Right? They want to monetize it because too many assets is high expense with low revenue. It's not a revenue generating operation for them. So a couple of business models have developed. One is to keep the chassis and charge for it, charge for the use, right? To add pricing into the mechanism. To divest themselves of their equipment and either sell them, turn them over to a third party, what we would call a gray chassis provider, where you don't have any ocean carrier's name on it. They just belong to a third party company. To pool their equipment with other ocean containers so that they don't have to invest in as many pieces of equipment. They can get rid of some of it and just pool it with others so that it's available for that peak demand. Right? So they're contributors to a pool. Right? Or some combination of all of these. And there are a couple of evolving models, right? So Maersk, which I mentioned is the largest ocean container company in the world, had under its possession about 90,000 pieces of equipment prior to 2009. And their model was to develop a program called Chassis Link. So they developed a subsidiary, turned over all of their equipment to the subsidiary, and the subsidiary charged truckers $11 a day to use the equipment. Now, truckers at first balked, but then if you talk to them after, most of them said, it's okay, because even though we're paying $11, once we have that piece of equipment in our possession, we can use it however we want. We don't have to constantly reposition it back to the port to get it to the terminal operator that originally discharged it or owns it. So it made them more efficient, even though they were now being charged for equipment that they didn't have to pay for. OOCL, which is a Chinese company, started requiring motor carriers, truckers to provide their own chassis or to rent them via a third party. Right? So they followed the divestiture model. MSC, which is a French company, they continue to provide the chassis at no cost for those store door delivery moves. Those are the ones for the large volume customers where the client contracts directly with the ocean carrier for the full entire trip, from ocean onto the land side. CY is container yard. And then an evergreen, or the APL model, although APL has decided now to get out of the business, they decided that it was still in their best interest to keep the current business model. One of the things that a terminal with a lot of space can do is store their chassis or store their containers on the chassis waiting for the truck driver to pick them up, as opposed to stacking the containers. Because when you stack the containers, the truck driver has to wait, and thus the person receiving the goods has to wait until the containers are repositioned and it's put on the chassis. When you have what's called a wheeled operation, where the containers, if you have enough land to store the containers on the chassis, the truck driver can pull in, connect, and leave. There's also a labor savings with that. This will happen if you have a wheeled operation, right? If you have a chassis on wheels. Truck drivers can come in any time of the day because you don't need longshore labor to put the container on the chassis, right? So this is still a good business model if you have enough land to be able to not stack your containers. And then the focus of our research has sort of been on the potential benefits of chassis pools, right? Which allow you to conserve assets, it allows you to conserve land. From an economic perspective, it's a rationalization of terminal operations. There's also some improved safety by having standard equipment recognized by a number of different terminal operators. You get reduced congestion and hopefully diesel emissions because you're not constantly repositioning equipment. You reduce bare drays, so those are those drays, those trips that come back just to bring the chassis back. That's not a revenue trip necessarily for the truck driver. And that in turn facilitates what we would call street turns, where for a truck driver, the best of all possible worlds is you're able to drop off a container that you've picked up at the port, an import container, drop it off, and at the same location pick up an export container that's going back and being driven on the same chassis. Right? If you can facilitate a street turn, those are two payable trips to the truck driver. Right? Pooling options have been approved by the Federal Maritime Commission, so that regulatory hurdle has been overcome. And this is similar to agreements that the 1984 U.S. Shipping Act allowed, where companies, different ocean carriers, can share space on their vessels, and it's not necessarily collusion. And the options that are allowed for companies to pool their equipment is what we would call a neutral pool, or a gray pool where a lessor provides chassis at a daily rate. So this is the third-party model. A co-op pool where users contribute their equipment and share their assets, or a hybrid pool, which is a combination of both, and that's what we have in Southern California. Right now, most of the chassis pools that exist on the East Coast for a couple of different reasons. One is that, to give you an example, 95% of the trips that are made on chassis in the New York region stay within the region. Makes it much easier to trace and track the equipment. In a place like California, where a local trip, is within a 500-mile radius, it becomes much more complex. The size and volume of the operations and the numbers of pieces of equipment have been a hindrance in encouraging terminal operators and ocean carriers to engage in chassis pooling. So what's happened as an step is that we have contributed pools at the ports of LA and Long Beach that reflect ocean carriers that already have an alliance to share space on their vessels. So if they were sharing space on their vessels, they decided that they would move towards sharing equipment once it got to on land. So you've got the Global Alliance, the West Coast, and the New World Alliance. And then you've got, of those 14 terminals, you have some terminals that have said, all right, as long as equipment is coming back and forth to our terminal from different ocean carriers, we'll allow those chassis to be pooled. So as long as you're a customer of our marine terminal, you can pool your chassis, even if it's, because you have different ocean carriers that call at the same marine terminal. We've got some examples of those. So that's a lot of context, but I think it's important to set up why we wanted to look at the in-terminal operations. And so our research question was, what is the impact of current intra-terminal, right, intra-terminal truck and equipment movements on a terminal's overall productivity and performance, right? And as I said, this is research that was funded through Metrans. And we began, as most research does, with a sort of a literature review on terminal chassis management. And on the policy, we did a lot of work looking at other institutional impediments to shared private sector equipment arrangements that might come from areas other than transportation, to get a sense of what literature is out there. We did a large number of focus groups, interviews, and surveys with terminal managers and the people who are responsible for managing equipment at the terminals, because that's a job function. We did terminal observations of chassis movements at 3 different terminals of different sizes to sort of get a profile for different type of operations, ones that might be more wheeled, where containers are stored on chassis, versus one where it's grounded operations. We interviewed the truck driving community to see how they interacted and what their wait times were once they were on site. And then we went and actually mapped the terminal truck and equipment movements based on the input that we had received and our terminal observations. And then Lei, my partner, did a scenario development for terminal operations, created actually some software for it to look at the potential benefits of improved chassis management. So the system mapping approach was where sort of once we had taken in all of the data, done the interviews, and done our observations, we created terminal profiles, terminal maps for different types of operations. We looked at, in all cases, there were 6 different nodes, right? So there's an in-gate and an out-gate for the trucks. There's the flip line that I showed you about, the chassis storage area, and then the export and import storage area. These are the staging areas for goods coming off of the ship and goods that are going to be placed onto the ship. We looked at the possible connections between all of those nodes based on the type of transaction that is taking place at the terminal. And there are 8 principal transactions, right? There are single and dual transactions. If you are just either dropping off, or picking up a container, that's a different number of movements than if you're doing what we call a dual transaction, where you drop off a container that's being put on a ship while picking up an import container that you're going to deliver to a store or a distribution center or a warehouse. And then we looked at single and dual with or without foreign chassis. So what are the series of movements that are required if you have to engage with a flip line, or if you can just load or pick up the container or unload the container at the import or export stack? Right? And we sort of did some basic scenario development. So to give you, here's an idea that if you were actually doing a dual transaction, dropping an export and picking up an import without a chassis, right? You've got 3 truck moves, but no yard equipment moves. No UTR, utility truck, cargo handling equipment, because the flip line isn't involved, right? If you're going to do the same transaction, the drop off and pick up, but you need to use the flip line because you have a foreign chassis, you're looking at a total of 7 different moves as opposed to 3. And it's both increases in moves on the truck side and on the container handling side. And then, so we developed scenarios, right, and ran simulations to be able to compare the impacts of these different types of operations. We considered all those 8 possible transaction types. We looked at both wheeled and grounded operations. And we looked at the potential number of transactions per day based on the profiles that we had and the data we had gathered for our 3 terminal observations. So we wanted to run the numbers, whether there were 800 transactions per day shift, and this is a 9-hour shift we're talking about, 1,000 transactions or 12 transactions, and then created 2 different scenarios. One where you had a port-wide or terminal-wide chassis pool, and one where you had the LA Long Beach model, where you only had contributed pools that were for the people who are already working in individual terminal or an existing alliance. And then we looked at whether, in the scenario, whether there were 0% foreign chassis, 10 or 20% foreign chassis in the mix. And then looked at the results in terms of truck turn time, what it meant, total system move time, and total system wait time. Okay. This was Lei's, but I figured some of you might be interested in how the simulation was developed. So it was traffic simulator software that allowed the trucks and equipment to travel within a terminal network based upon those 6 nodes and the different transactions. She used Visual C++. And then we had to build in a number of assumptions into the research, right? So for a node, we assumed the minimum time it takes to perform a service at a node. I mentioned, for example, we looked at an average of about 2 minutes for a flip, but somewhere in the range of 10 minutes for the queue, right, based upon our observations. At the link, we looked at the relative distance between the nodes. That's where that 1.5 to 3 miles comes from, based on the terminal layout and the time spent at each of the links, and then the generalized movements for each transaction type. We had some of the other inputs were export data, looking at the total of export boxes in the simulation period, the proportion of grounded versus wheeled operations for the different terminal types that we had observed, because they're very different based on as I said, on the size of the operation. And then we also had third-party data that came, sort of number of available units of time per work period, which came from Longshore Pacific Maritime Association records. Those are the ones that keep records on the number of shifts that Longshore Union work. Right? And we also had prior research that had been done, that we had done, Jen Giuliano and I, where we were observing turn times at marine terminals both inside and outside of the gate. So we had that data to draw upon to create our assumptions. We assumed a balanced import and export mix, even though we do a lot more imports in Southern California than exports. Bringing back empty containers to the terminal, we count it as exports in terms of creating that balance. We assume that 70% of import container volume were handled at a terminal, stored on chassis, 30% grounded, while 100% of all export containers are grounded. This is based on industry standards and terminal operations in Southern California. We looked at shares of different type of transactions based on the research that we had conducted on turn time analysis. So we had data from 2 terminals that we used in creating our assumptions. And we looked at maximum operational capacity for each facility based on number and productivity equipment. We were able to get information on the numbers of container handling equipment that's used on site. And so sort of some of the highlights of the findings, right, was that sort of in a nutshell, if you look at 800 transactions, the scenarios tell us that you're going to get a 10% increase in the share of transactions that involve, for 800 transactions, a 10% increase in the share of transactions that use a foreign chassis will increase that transaction time by 13%. It's 11% for 1,000 transactions and 5% for 1,200 transactions. Right? Which means that it is true that current chassis management practices have a negative impact on overall terminal performance and therefore productivity, right? As the percentage of transactions that involve those foreign chassis increases, the interterminal network time increases as well, which means it's less productivity in the system, right? And it's particularly significant for smaller terminals that are unable to be reactive or respond to changes in land use needs, right? To be able to move locations for import or export storage areas, right? The percentage of transactions that involve foreign chassis, you see the middle bullet, grows from 0 to 10 to 20. The change in total network movement time increases faster for terminals with less throughput capacity, and that's very often a function of size. What was interesting to us was that we assumed or we expected that we would see an increase in truck turn time as well. And that wasn't the case. There was no clear pattern that truck turn time increased as you increase the percentage of transactions that involve foreign chassis. But there was a clear pattern that container handling equipment, cargo handling equipment, utility trucks, their movement and their queue time increased, which increased the overall system runtime and the wait time for the cargo handling equipment, right? So give you a sense in terms of total duration of overall efficiency, the time reduction, right, for trucks is not time saved or eliminated. It's time that's transferred to the cargo handling equipment, which made some sense to us after we had looked at it, because what happens is if you have a truck coming in that would normally have to drop off the container at the export or import yard but is told to reposition and go to another terminal, it's less time spent inside the gates that's counted as truck turn time for that terminal. Now, that's not to say that it's going to increase the overall transaction time for that truck when you take into account the movements from one terminal to another. that makes sense. Yeah, it is. Yeah. Well, these are but for the number of transactions that we're talking about, for 800, for 1,000, for total transactions. Now, on the environmental side, eliminating those additional and unnecessary cargo handling equipment could have significant environmental benefits. And this is not numbers that we ran, but we thought we'd sort of raise the issue for further study, because based on studies that we've seen from CARB and also the ports themselves, the UTRs generate about a 50% of cargo handling equipment emissions themselves. So it's not just the truck turn time that's important from an environmental perspective and eliminating truck queuing, which is the focus of a lot of legislation and a lot of the programs, but it's also the cargo handling equipment. And there's been efforts to incorporate the cargo handling equipment into alternative fuel standards and requirements that CARB has put out, but not much effort on the number of moves and transactions that are made, right? And these are individual pieces of equipment at the two ports, right? So with all of these incentives and potential productivity benefits, why don't we have more chassis sharing agreements? And there are a couple of things to point to, and like almost everything that has to do with this industry, it's a lot about the structure of the industry and the relationships that the different stakeholders have, and the imbalances in who makes the decisions and who responds to the decisions. So for ocean carriers, it's a cost control issues that they don't, even though they own the equipment, they're less hesitant to be turning over responsibility to third parties that might be bringing in equipment that will be transported on the ocean carrier ships that may not be of the same quality. Even though the roadability legislation should take care of that, that's still a concern from ocean carriers. And even for the companies that have divested themselves of chassis, it hasn't eliminated the equipment management function. It's still a cost function for them because there's forecasting of future chassis needs, there's relationship management with the third-party carriers, and with the trucking community. On the trucking side, there's a real concern about the payment structure for maintenance and repair. Who's going to be responsible through a third party? At least the terminal operators and the ocean carriers were sort of the devil you know as opposed to the devil you don't. And also changes in CSA scores. CSA is compliance, safety, and accountability. I believe it's regulations that the Federal Motor Carrier Safety Administration came down with a few years ago that actually assigns ratings to truck drivers based on the number of violations that they've had in terms of equipment maintenance and repair. And so, again, it was one of those cases where at least they knew how they could be responsible by making sure the equipment was sound before they left the terminal gate. Uncertain the level of responsibility with a third-party coordinator. There's also an issue for truckers, many of whom are independent owner-operators, that if they're being asked to bring chassis to the transaction, where do they store them? Right? What we've seen is some companies have decided, all right, it's in our best interest if we're handling particular goods, overweight goods, refrigerated goods, maybe we'll invest in our own containers, our own chassis. Otherwise, it's not in our best interest. So that's been a concern, is where are we going to be? Are we just going to be shifting the repositioning from inside the gate to outside the gate? Terminal operators have expressed to us some concerns that a trucker-provided chassis could complicate terminal transactions with wheeled operations and increase turn times. A terminal operator that decides they can provide good service to a company by putting containers on chassis controls the use of the land and the equipment that's used to run wheeled operations. If a trucker is providing the chassis, it doesn't allow them that control. There are still some lingering issues with regard to labor impacts. Because the maintenance and repair for chassis currently takes place on the terminal, It's subject to a union labor agreement with the International Association of Machinists. If that activity is moved off-site to a third-party chassis storage area, both the IAM and the International Longshore and Warehouse Union have expressed interest in making sure that their union is responsible for that maintenance and repair. The chassis operators say it shouldn't be unionized at all. It should because it's done off-site. This is a constant debate that happens in the supply chain. There are lingering issues on East Coast versus West Coast adoption of standards for third-party chassis maintenance and management. I mentioned the difference with regard to distance and size of operations. Another big difference is between the two coasts is that on the East Coast you have examples of actually statewide port authorities, Georgia and South Carolina, for example. And what that means is you have standards that are being set tied to labor for maintenance and repair because the state employees are not longshore union members. It gets a little confusing, but the point is that you don't have a single standard for all of the terminal operations in all parts of the country, which means that we don't have a single approach to adopting chassis pools across the board. And then there's been a real impact from a technology perspective that we don't have yet cost-effective subscription systems that handle the different number of transactions, particularly for management over greater distances. We don't have a price point for tracking and tracing technology that would allow for widespread distribution of those systems. And so until sort of the market catches up, we're not going to see the type of technology that's going to make the stakeholders comfortable in sharing their equipment. So these are issues across the board in Southern California. There's a potential benefit from focusing on yard equipment in addition to trucks. And in fact, the two ports have issued a request for proposal for a chassis management strategy that would hopefully look at both inside and outside the gate operations from an efficiency and an air quality perspective. So they are moving forward. And they're doing it because of the number of stakeholders involved. The ports are taking the lead. The railroads have been resistant to going chassisless, so bringing them into the discussion is a big issue. Railroad depots and yards are another big place for storage, and the railroads want those chassis available to move the goods trailer on flat car. I mentioned the labor issue, labor maintaining the right to be responsible for M&R on chassis that are maintained outside of the terminal gates. And then there are unresolved issues with regard to what happens if you to policies with regard to storage, per diem charges for equipment that's left at a marine terminal or a rail yard. Will those automatically transfer to a third party responsible for chassis management? So next steps on us for our research, we're going to be looking at, as I mentioned, this shift of inefficiencies from inside the gate to outside the gate. We want to look at next, which is getting a better handle on the interterminal movement of chassis. Right? So once that truck driver brings the foreign chassis back to where it belongs, what happens then, and what does that add to the transaction from a truck driver perspective? And the movement from chassis to and from terminal and inland locations to get a better handle on the repositioning of equipment between marine terminals and intermodal yards and how that adds to the equation. And with that, I will close, a few minutes over 2:30, but see if you have any questions. Now you know more about chassis than you ever thought you would.
We've done that analysis. I don't know anybody here as well as you did, but we would have probably added a last piece, which was the energy implications of that whole thing.
Right.
And how much energy you might save.
So the question, for those who might be listening outside of the room, was about whether we had looked at the possible energy implications. And the answer is no. It's a natural next step. It wasn't in the scope of this study. because there are potential benefits if you throw into the mix a different type of fuel or a different type of standard. Our point, I think, was sort of focusing on what if you eliminate that move inside the terminal altogether. Yeah,
reduction in movement.
I would think so. Anthony. Right. Yeah, and I have a whole series of slides that show sort of these new these new types of materials that are being used to create collapsible containers, foldable containers, so when you store them, you can stack them. The real question is the marine environment is pretty tough. And so there's been a hesitancy to use anything but sort of the standard ocean container because of that ocean voyage. And because
They stack on like 20.
no, not in the U.S.
Well, I mean,
No,
the ocean, they must, how do they?
on the ocean vessel side.
Containers are getting stacked.
Yeah, they are stacked pretty high, about 20. I mean, on the land side, it's 5 or 6, if that's what you're referring to. But even so, it's the integrity of the contents within case, seepage. Are they protected when they're lashed onto the ship and when they're moved from the ship to the chassis, to the rail car, to the truck? So, I think that's actually one thing that is coming, but not part of this equation. It's a good question, though.
You had a great early slide that showed
Singapore.
a big gap there. So I
Right.
was wondering, are they doing better because they have shorter range distances, or learning the language as they go, or bigger cargo ships, or what?
So the question was, what else explains the gap in productivity between not only Singapore but Asian ports in general and North American ports? It's a couple of different things. One is utilization of the land. They don't have wheeled operations. But the other big thing that's masked in the productivity standards is that a place like Singapore and Hong Kong are actually transshipment ports. So they're ports that receive goods that might be coming from manufacturing sources in Vietnam, Thailand, Cambodia, that all come together and meet in Singapore. They're packaged together for final shipment to North America or Europe. So what that means is you actually get, you don't get a lot of landside activity. You don't get a lot of stacking or storage. You don't get a lot of drays because it's not going out. They're simply being transshipped. When you do that, you can be much more productive. And in some cases, the move is counted twice. So you get the benefit of getting the move off the vessel and back onto the other vessel, right? Which skews the productivity numbers. But having said that, there are also different safety standards, right? So you can stack higher. Because of union and longshore regulations here, the adoption of automation has been much slower than in other places. You can be more productive when you've got triple tandem cranes unloading ships and putting the containers on chassis. I would say it's a combination of technology, operational, and the type of port, right? I mean, LA Long Beach is fairly, it's productive given the complexity of operations and connection between the water side and the land side. It's a good question. Who's absorbing the cost of the inefficiencies? In many cases, it's the truck driver, right? The truck driver in this scenario, at least the draymen, are price takers. And they're the ones, because they're paid by the trip and not by the mile, any delays in the system are borne by them, right? And that's been another reason why there hasn't been as much of an incentive for terminal operators to improve efficiency, because delays at the gate are delays to the truck driver. It's not delays to the ocean carrier or the terminal operator. But having said that, once there is a demand to be able to store more containers, the inefficient system is borne by the terminal operator and the ocean carrier. If they're not able to move goods, if goods have to stay on terminal longer than they would because there's not enough equipment to process them, that's a system-wide problem, and the terminal operator can't meet the demands of their customer. If you're Walmart or Target or Kohl's or whoever it is, and you're paying for premium service, and the terminal operator sees that we just don't have enough chassis because they're out on the road repositioning, that becomes a problem for the terminal operator. Anthony. Mm-hmm.
Significance of this piece of it relative to the cost of doing business?
This is a big topic of this question of competitiveness and what inefficient equipment management means for the overall supply chain is a big issue for the industry in Southern California. They know that it's hurting. It's hurting, if not in practice and perception, that it's a more complex place to do business in Southern California, which is why I think the ports have issued an RFP and why there's a working group on chassis management. Specifically with regard to the Panama Canal. Look, shippers have always had options at their disposal. And what matters to them is, in combination, transit time, cost, reliability of service, and available infrastructure. I think those are the four biggest pieces. So the Panama Canal makes sense for goods that you're willing to have spend longer time on a vessel going to the East Coast, but that people might not be willing to pay as much for, right? So lower cost apparel, that might be a good option for you, right? If you have an expanded Panama Canal. So it can go on a larger vessel, reduce your unit cost and savings that way. But that's not the only factor, right? It's going to be whatever you're shipping, electronics that need to get to market that people are willing to pay a premium price for are still likely, I think, to unload on the West Coast somewhere. So it's a lot about competitiveness. The first step is not being complacent, I think. So making sure that you look at the right adoption of technology. Do you have the right operational standards in place? And that will make you sort of competitive. And remember, this is all about, in the West Coast context, the battle is over discretionary cargo. Cargo that doesn't have to go through your port. We have a huge market in Southern California for consumer goods. They're going to load and unload at Southern California. It's not going to make sense to bring them in through Seattle, Tacoma, and truck them down. But the stuff that's going to Chicago or Kansas City or anywhere else, that's what the battle is over. Yeah, I mean, the canal's open in both directions, right? Which people on the East Coast tend not to talk about that much. Yeah, I think that is a potential, and I think it's an undervalued part of the discussion. It's interesting because as wage rates in Asia shift, right? That southwest corner of manufacturing activity from Hong Kong and Shenzhen up, where the center of Asian production has been, is moving westward in China and into other parts of Asia, which means as you move in that direction, the Suez Canal becomes more of a viable alternative than the Panama Canal. So we may be trying to capture goods through Suez that will make a first stop in Hamburg and New York before coming here. I mean, it's a pretty complex discussion. And there are all of these other things that are happening in tandem. The Panama Canal will only be cost-effective depending upon the pricing structure. The Panamanian government has to retire the debt, right? So what is the price point that they're going to be able to use that allows them to capture business, still retire that debt? If it's higher than most are willing to pay, then the discussion may be moot. The goods may still be coming to the West Coast. And those larger vessels I talked about, the 16,000, 18,000 TEUs, are too big to go through an expanded Panama Canal anyway. Right? So they're going to go on a couple major ports in Northern Europe, on the East Coast, and LA Long Beach and Seattle Tacoma, or Prince Rupert in northern Canada. Well, there is, I was saying if there's an upside to global warming, it's that new trade routes open. No, in fact, the discussion of a northern passage, and in fact, they are shipping some oil products from Russia using Northern Passage and icebreakers. But it's been a big boon to the conference business in Anchorage because there's lots of people discussing this in Alaska. But it is a real issue to look at. The number of service days on the Great Lakes shipping season have increased because of temperatures. So, there's clearly things that are happening. The relationship between trade and climate change. Deborah?
I was just thinking about this whole discussion of going all the way down to the Panama Canal or to bring your ship to the East Coast versus putting your stuff on a long haul train. But I think the other option to get from west coast to east coast. What is the price differential between those two modes? Roughly, in terms of number of times.
Well, it's going to be one of those answers you don't like that depends upon the number of containers that are on the ship and the value of the product in it. And the time, the transit time. It could be, hundreds of dollars per container, which on a margin might have some impact, right? But that's less of a concern in some ways than predictability. What cargo doesn't like is unpredictable transit times. Their shipper is much more willing to pay the same amount as long as it's consistent. Or with regard to transit time, if you can get across the Pacific in sometimes 12 days and sometimes 15 days, that's great, but they would rather have it always be 14 days if they knew that they could plan on that. Because it's the fluctuation that wreaks havoc with the costing and the pricing.
And the trains are less reliable.
The trains are reliable, but you usually have to wait until you have enough volume to build a train before it goes. One of the benefits of shipping from Southern California is that there's always enough volume to give you predictability on when a train's going to go. That's not the case everywhere. But it is quicker. Or some combination of truck and rail. Modal connection. The pricing, though, through the transit costs through the Panama Canal are which is sort of the big equation. I think the biggest transit charge through the canal that was ever paid was actually not a container ship. It was a Disney cruise line, a cruise ship. And I think based on the number of passengers and weight, it was about I think $10,000 or something like that to transit the canal. So that equation, that's an important part of the equation. Yes? There is increased technology and automation. So the answer to your question is yes, it has an impact because it does reduce labor costs. Now, it's a higher level of technology. There are still maintenance and repair issues. For our study, it was about, as I said to Anthony, it was about eliminating that trip altogether. But automation does help terminal operations significantly. Not only on the yard equipment side, but on cranes. Right? I think there's tremendous use and potential for GPS, GIS. One of the issues that is frustrating if you're looking at the industry is that when a truck driver comes into a terminal gate, it's at that point that a message goes to the container stacks and says, this person is here to pick up this container. And then all of the jockeying of the containers has to happen. In a more efficient system, you would have, once the truck is dispatched, you would be able to use technology to say this is the average time it's going to take based on current traffic conditions for the truck driver to get from where they're going to the terminal. We'll unload the container now and have it ready. The contract doesn't allow that. There's a lot of physical paper transfers that the contract doesn't allow. So the yard equipment is a big question, but it has to be discussed as part of a broader use of technology through the Longshore Labor Agreement. And this is a contract negotiation year, and so that will always be a part of the discussion and one of the stumbling blocks. It's interesting. So the question is about state regulatory oversight. The three major ports in California, LA, Long Beach, and Oakland, which are the three that move more than 1 million TEUs, operate under state law, in fact, under 1911 law, the State Tidelands Law. So they are actually, the authority to operate them is ceded to local government, to the City of LA, City of Long Beach, Port Authority of Oakland, by the state government. And the operators of the port, of the tidelands, have to do it for the benefit of the entire population of California, not just for local residents. And I say that because that means that whenever we have sort of efforts from a policy perspective to change the behavior of operators along the supply chain, it's tended to come at the state level and not local level, because that's where the jurisdictional authority is. It's been difficult. We did a lot of work looking at legislation that mandated the elimination of queuing at the ports, right? Which we used a combination of carrot and stick. And the issue has always been compliance and enforcement. How do you do it? The issue has been, as well, the different incentives that the truck drivers have relative to the terminal operators. So the way it's happened in California is that in the cases where we've had the Clean Truck program that's been successful at overhauling the trucking fleet so it's much cleaner, and with use of appointments and things like that to make the supply chain more efficient, what's often happened is that the legislature has come in and said, we're going to regulate this. And then the industry says, okay, thanks, but no thanks. If you let us get to the same point but control it internally, the state has sort of said, okay. Let me give you one quick example to explain that. Because of the cost of union labor, the terminals have always been, up until about 2005, open from 8 a.m. to 6 p.m., right? Because it costs more to move the cargo in the off-peak, in the evening, and on the weekends. And so there was a piece of legislation that was run that said, okay, we're going to require terminal operators to either establish appointments or operate in the off-peak, right? And we're going to charge a surcharge. We're going to set up a pricing mechanism where that if you want to pick up your containers during the day, when there's more congestion and everybody else is out on the road, you've got to pay for that privilege. And we're going to take that surcharge and we're going to bring it back to Sacramento, and we're going to use the money to pay for environmental mitigation, infrastructure improvements, and security. And the industry saw that there had been some success at getting legislation passed, and the terminal operator said, okay, what if we agree to operate all the terminals 4 nights a week and 1 weekend? We'll collect the money. We'll create a surcharge, create essentially congestion pricing, but we'll collect the money. And we'll return the money to the terminal operators to pay for the cost of the additional labor in the off-peak. And the assembly member who sponsored the bill in Southern California said, okay, if you can make it work, make it work. And we did. The program was called Pier Pass. Almost overnight, right, you could tell there was latent demand, pent-up demand. About 40% of the cargo that was eligible to move to the evening and weekend shifted to the evening and weekend. So there's been a sense, this is, I don't, it's a bit of a cliche, but you don't want to kill the golden goose. And people understand, at least in Southern California, that it's vital to the economy. And you want to encourage behavioral change, emphasis on the word encourage. And if it sometimes takes the legislative piece to force industry to behave, that's how policy change is happening. And the other thing we were talking about at lunch is that, so what you're getting is actually extra regulatory policy that's being developed by ports. right? The Clean Truck Program, the policy to overhaul the trucking fleet and to upgrade it came about as a result of a joint effort that the two ports worked on together that was independent of a regional planning effort or statewide legislation. And ARB is sort of using, in many ways, it as a model in the same language. Bless you. Any other questions? Okay. Thank you.
I think that they.
Yeah, so that's I'd be interested in looking at that.
Prior work focusing on.
Well, I do mostly work with fleets here, but I've been over the Hybrid Electric Vehicle Research Center for electric vehicles.
Yeah, so there's, well, in electric